All right, so we will get started. We'll look at question on number 5. So we continue from the last Friday revision class, right? So look at question 5 over here. So you're saying that about alkanes and also alkenes. So again, just to remind those of you who are not familiar with the hydrocarbons, so alkane is actually single carbon bond. Okay. Then how about alkene? Alkene should be at least double carbon bond like this. Okay. Should be at least double carbon bond between the carbon atom. Right. Short chain of alkane and alkene can form a long chain of alkene. So long chain of alkane here maybe like they talk about like C, for example, C10 example. Okay. Then C10 is we call it decagon, right? In your mathematics. So get deca means is 10. So the general formula for alkanes is actually CnH2n plus 1. And this is a general formula for alkane. Okay, single bond one, single bond, meaning that carbon linked with carbon, right? So this is general formula. So you know that if the carbon is 10, for example, long chain, 10, then the hydrogen 2n, okay? 2n plus 1. Sorry, 2n plus 2, not plus 1. Plus 1 is alcohol already, plus 2, right? So that means hydrogen should equal to 20, 22 already, right? So this is so-called the decacane. So name the type of chemical reaction that form short chain of alkane and alkene form long chain of alkene. So look at here. So look at our previous revision note on our intensive class. To break down the hydrocarbon, we actually can use two methods. Okay, two chemical processes. The first one is actually so-called the fractional distillation. So normally fractional distillation will apply in petroleum, in liquid hydrocarbon, such as petroleum. Okay, so fractional distillation always apply to break down hydrocarbon in petroleum. They're using not so high temperature. It's considered lower temperature. Of course, the fractional distillation, we already know this is the diagram will always look like this. Okay, so their temperature is not reaching very high. So it's between like less than 300 degrees Celsius. Then we can actually get from the diesel oil, kerosene, petrol, and petroleum gas. So fractional distillation normally using lower temperature. Then the second process or the second method is that we are using cracking. Cracking process actually using higher temperature. Okay, higher temperature and using catalyst. So how high we consider higher temperature? And cracking process are more effective. It's more effective as compared to the fractional distillation. Because fractional distillation, the product that we are getting is actually cannot be break it down into small, fine change or smaller changes, but the product that normally we get from fractional distillation is like just like for combustion or for fuel, okay, like the petroleum and also diesel. For cracking itself, cracking is actually also a process of breaking down the long chains of hydrocarbon, but they're actually using higher temperature and pressure. So they're also using catalysts such as the aluminum oxide, the silicon 4 oxide. So silicon 4 oxide is considered the silica, right? The silica, like the crystal, the sand that we can to use to make glasses. All right. So now, so come back to this question here. So what is the process? So our answer straight away we can write down cracking. Cracking, right? You straight away write down cracking. Because why? Because it's saying that long chain alkanes to short chain alkane and alkenes. So the decacane, okay, the decanes actually have 10 carbon. So the decane just now is this one, right? See, just now we already write down the decane. So it's formed ethane and also ethene as only product in this type of chemical reaction. So that means they form ethane and ethene, the only products, right? So now they ask us to write the chemical equation for this reaction. So first of all, we need to derive from the decane here. Decane, we know that carbon is actually 10, right? So we need to write down the general formula first. So the general formula for the alkane, how we're going to know it's actually alkane? Because you look at the A and E here. So the A and E here is actually indicate this is the alkane group. So the alkane general formula is CnH2n plus 2. Okay, C number of carbon, then the number of hydrogen equal to 2n plus 2. Right. So teacher already write down just now here. So you just write down C carbon, we have 10 hydrogen. So based on the general formula, 2n means 2 times 10 is 20, then plus 2 is equal to 22. Right. So that means we're going to use the cracking process. So cracking then will give us a product. So what is a product? So this one you just draw an arrow, the product. So make sure that this is the ethane. Okay, ethane. Ethane, and this is the ethene. So the number of carbon that we can have is, you see, ethane. Ethene. Okay, E here is actually represent how many carbon. First of all, you need to decide how many carbon they have here first. So what is our slogan? Our slogan is Mama eat papaya, granite, but Papa. Okay, Mama mean me. Eat mean ethane. So this is the ETH, right? ETH is actually 2. 1, 2, 3, 4, 5. So papaya, pro. Propane, pro. Okay. This one, boot. Boot. Boot means 4 carbon. Papaya means here pen. Papa means penta. Okay. So we know that here, this one, you see, the ETH here is actually 2 carbon. So we need to write down the carbon first. So the carbon here must be 2, then plus another ethene. Ethene here, the carbon here also have to be 2. All right. So then you need to decide what is the general formula for the single bond carbon. So general formula is CnH2n plus 2. Okay, we got the plus 2. Then how about ethene? Ethene is CnH2n only. So we don't have the plus 2. Okay, we don't have the plus 2. So then it should be easier for us. So we know that CnH2n for ethene. So we know that 2 carbon, that means hydrogen here should be 2 by 2 equal to equal to 4, correct? But yeah, so equal to 4. So you can write down equal to 4 over here. Okay, then after that, how about the ethane? How about the ethane? C is 2. 2 by 2 is 4 plus 2 is actually equal to H6. H6. So now we need to check whether it's balanced or not. Whether it's balanced or not. So you add up together, whether they have 10 carbon. So here is 10 carbon, you know. See, check 10 carbon. This one 2 only. This one 2, and this one also 2. So how to make it become 10 carbon? So we cannot change this one. We cannot change the ethane, right? So maybe a teacher write down for you. This guys here, mean this name here is ethane. Ethane is actually saturated. saturated hydrocarbon. That means they cannot change anymore because the ethane, the alkane group is saturated. Therefore, when you balancing the chemical equation, you cannot change the ethane because they are under the alkane group is considered saturated hydrocarbon. Now, this one, the ethene, this one is equal to the ethene group. Ethene group meaning that they have double carbon bond. That means they are unsaturated hydrocarbon. That means they are flexible to change. Flexible to change. So now here we got 2 carbon only. Here also 2 carbon. So add up is only 2 and 2 only 4. So we need 6. Okay, we need, you see, 10 minus 2 minus 2, we need 6 more. So how to get it? So this one, maybe we have to change a little bit. So we cannot add any number here. We cannot add any number here because it's saturated. So we have to add number over here. Okay, we have to add number in front of here because it's 18. Okay, you try 1. 1 we cannot try. So how about 2? Cannot, because 2 times 2 become 4. 4 times plus 1 plus 2 is equal 6 only. Then you try 3. 3 by 2, 6. 6 plus 2, 8. Cannot also. All right, so 4, yes. So now you change 4. 4 times 2, 8. 8 plus 2, 10. All right, so then you get the equation already. So meaning here in front of here, you need to add 4 in front. 4 in front. So yeah. So because some of our friends is saying that why we cannot add the number in front of the ethane, because the ethane is considered saturated hydrocarbon. So we need to add the ethene, right? So 4 here. All right. Yeah, Hansi and their friend is just coming in. Yes. Do you bring your worksheet? Last week one? The exercise. The exercise. We are on the question 5, huh? Question 5. Okay, we continue. We went down to set it down. Right, that's how we discussed about the question 5. How we're going to write the equation of the decaying here. Okay, decaying, deca here means 10 carbon just now. So look at how we're going to write that. You must have the skill to write. Because why? Because I pay a lot of time to emphasize on this topic. In paper 4, every time the IGCSE exam, they must have 1 or 2 questions. They're asking you about the organic chemistry. Therefore, organic chemistry is very important. We need to master this topic so that every time, maybe they come up with 2 questions, question 5 or question 6. Or sometimes it's 1 question, question 6 itself, right? So proceed to look at question number B. So now, ethane react with chlorine at room temperature to form chloroethene. Chloroethane here. So, and one other products. So you see, when you're acting with chlorine, you should remember that we studied in earlier of this chapter, they actually react with chlorine and they will undergo one process, what we call photochemical reaction. Photochemical reaction. So the photochemical reaction needs UV light, ultraviolet light. You still remember? I forgot where is the section on the UV light already. So you're going to look for the UV light. Yeah. Okay. Okay, this one, right? I mean, they were going to have the halogenation, addition of halogen. Addition of halogen. Halogen can be group 7 element. Okay, group 7 element, for example, like the chlorine. Okay, for example, like the bromine over here. So we call it as addition of halogen. So how many addition process to the alkene? So why alkene? Again, why alkene is not alkane? Because alkane is considered saturated hydrocarbon. When it's saturated, they have no flexibility to change anymore. So, but the alkene, just now I repeat, they have double carbon bond. So at least one double carbon bond, so they are flexible to change. Therefore, they can change to others. I mean, react with other things in the process of addition of hydrogen, addition of halogen, addition of the halide meaning that the halogen of group number 7, right? Addition of water, for example. Addition of water normally will be hydration, like the to get alcohol, the ethanol. Okay. No, addition of water normally in the process of addition, in the process of processing the ethanol. Okay. Oxidation. All right. So now come back to our question. Here, come back to our question. So they're asking you chlorine at room temperature to form chloroethane. So what is the product? So we know that this product is actually the hydrogen chloride, because the chlorine is actually what? Chlorine is Cl2, right? Cl2. So one they're going to pair with the ethane. Another one they're going to pair with the hydrogen ion. So this one here is another product. Okay, this one will become the hydrogen chloride. Okay, so the chlorine gas will break it into chloride ions because it's Cl2. So one of the chloride ion we're going to pair with the ethane to become chloroethane. Another chlorine ion we're going to pair with the hydrogen here. You see hydrogen here. So addition process. So to replace one of the hydrogen ion. So another product form will be the hydrogen chloride gas. Hydrogen chloride is a gas. That means HCl. Hydrogen chloride, HCl. HCl, if you are dilute in, I mean, they will dissolve in water, they become hydrochloric acid. Yes. So HCl is the hydrogen chloride gas. Right. So state the condition that need for this reaction to take place. Condition, then they need what? Condition needed. They needed, just now we say the ultraviolet light, the UV light. Okay, you don't need to use the short form. You straight away write the ultraviolet light. Okay, next one. ethene react with chlorine at room temperature to form dichloroethane. Dichloroethane. So the equation is over here. You see, so state why it is an addition reaction. Why is actually the addition reaction? You see, this one is what? This one we got one reaction and two reactant. Then how many products? One products. So addition meaning that if we're going to have two reactants, they add up together, we have produced one product. So we call it is in the process of addition. So I suggest you to go and read in details for these 5 addition reactions that occur in alkene. Okay, why alkene? Just our teacher already explained, because they have at least double carbon bond, means they are flexible to change to other form of product. Alkane cannot. Alkane is considered saturated hydrocarbon, so they cannot change anymore, right? So our answer here, because we can say only one product is formed or produced. Okay, only one product is formed, so therefore we call it an addition reaction. Okay, you write down. Yeah, some of our friends, our girls today didn't come because they have their try exam in school, right? Sorry? Ultraviolet light is the UV light from the sun, like sun. Okay, next one, we're going to look at the calculation parts. Okay, so the chemical equation for this reaction can be represented and shown here. So the energy change for the reaction is actually negative, negative 180. So if negative, we know that is actually what? Negative. The energy become lesser. Negative meaning that where is the energy go? The energy will lose to the surrounding. When the reaction takes place, the energy is actually losing to the surrounding. So if they're losing to the surrounding, the energy come out, the heat energy. The energy that we're talking about here is the heat energy, the thermal energy. So the thermal energy released out to the surrounding. So what kind of reaction is this? We call it exothermic. Yes, correct. Exothermic meaning that the energy lose out from the reaction system to the environment, to the surrounding. So become negative. So now use the bonding strategy on the table to calculate the bonding here. So look at here. They give you the table, calculate the energy needed to break the bond. To break the bond, meaning that we need to start from the reaction here, reactant here. So just our teacher already circle for you, right? So this is the reactant number 1, and this is the reactant number 2. So this is so-called the breaking. Okay, to break the bonding, breaking bond. Okay, reaction happen, break the bond. So see carbon to hydrogen. So how many carbon to hydrogen? We have, for example, we have 1 here, we have 2 here, we have 3, and we have 4. So we know that the carbon and hydrogen is actually 4. 4 times how many? 4, 10. Okay, so maybe I zoom it bigger, right? So like this. Then after that, carbon and carbon. Carbon double bond with carbon. So carbon, how many? 1 only, right? You see, carbon and carbon only 1. So this one you have to plus 610. Then how about the chloride and chloride? So correct, only have one, right? So only have one. That means Cl and Cl, only one. So one, that means you add one. 240. Okay, you add up together. Where's your calculator? You don't have calculator, check out your what do you call? Check out your handphone. So now 4 times 410, then plus 610 plus 240. So how much you get? You get 24990, right? Okay, 2490. This one is energy, right? So kilojoule per mole. So you write down the answer here, 2490, right? So this one easy. So a lot of students are making mistake here. Careless mistake here. They didn't calculate as 4 times 410. So this one you must remember, we have four carbon and hydrogen bond here. Okay, 1, 2, 3, 4. Okay, if you don't know, you can circle it. Okay, circle it so that you identical. It is 4. Then next one, step number 2. Step number 2, use the answer in step 1, I mean the 2490 here, and the energy change for the reaction to determine the energy released when bonds are formed. So now, bonds are formed. So how? So bonds are formed, meaning that how many energy does now lose to the environment? 180, right? So 180. So what you need to do is that we will get the the energy bond equal to 2490. We need to plus 180, right? So the 180 originally is actually on the left hand side, correct? You see, from the question they give you negative 180. The negative 180 before the reaction take place is actually 180 belong to the reactant one, correct? The 180 kilojoule is actually belong to the reactant one. So that's why we need to add back the 180. So this one is actually breaking the bond, right? So we add back the 180. So how much? Before he lost, 明白吗？你讲他还没有不见掉180的时候，它是原本180是他的。So that means 2490 plus 180. So it become 2670. Okay, so you write down 2670. That means the energy that needed to release. So now step 3. So use your answer in step 2 and the bond energy value to determine the energy of the carbon with chloride bond. Carbon and chloride is here. You see, carbon and chloride is here. So first, we need to use the step 2 answer. Step 2 answer is 2670. Okay, 2670, correct? So now we need to minus. Now we need to minus off. So look at the right hand side now. Look at the right hand side now. Because this is a product from, correct? So the answer is actually ask us to determine the carbon and the chlorine. Okay, the carbon and the chlorine here, carbon and chloride bond. So first of all, we need to work out what is the energy that needed for the bonding. Okay, energy needed for the bonding. So what is the total energy just now? The total energy just now is actually 2670. So we need to use back this answer. So meaning that we need to use the 2670. So we need to minus. We need to minus of this one. over here. Okay, we need to minus of this one. So how many bonding from we're able to get from the carbon and hydrogen? This one is 1, this one is 2, this one is 3, this one is 4. So again, it's 4. So come back over here. Okay, maybe I zoom smaller a bit. So here become, so this one you need to put it into big bracket. So 4 times 410. Okay, then what else we have? The single carbon and single carbon. So we need to plus the single carbon. We need to plus the single carbon over here. Okay, we need to plus the single carbon over here. So single carbon is equal to this one, single carbon. So 350. Okay, then bracket. Then how about the carbon to the chloride? Carbon and chloride, we don't know, right? Carbon and chloride, we don't know. So the question actually asks us the C and L. Okay, the C and L. So yeah, so we calculate how much first. So 4 times 410 plus 350. So will be equal to 2,670 minus 1,990. So how much? How much? So 2,670 minus 1,990. So equal to 680, right? So this one is a kilojoule per mole. But is it the answer yet? Not yet. Not yet answer. Why? Because now you need to look at how many bonding between the carbon and the chloride. You see, the carbon and chloride, we have 2 bonding. Okay, so the carbon and chloride. So this is 1, this is 2. So meaning that 680 equal to 2. So we need to get 680 divided by 2. Okay, so the answer should be 340. So this is the final answer. Get it? This is the final answer. Because the 680 equal to 2 bonding of carbon and chloride. So this question is actually in total is 4 marks. Okay, get it? Okay, you must remember, you must know why we add back the 180 just now. A lot of students making mistake because they didn't add back the 180. They thought it's negative, so they just straight away minus the 180. So we're going to minus the 180. That means our answer will be wrong. Why? Because the 180 originally belong to the reaction 1 and 2. Just that originally meaning that before they actually react, the 180 is actually belong to the 2 reactant. So after the reaction takes place, then the 180 kilojoule lost out to the environment. So therefore, we need to add it back to the original reactant. Therefore, it's plus. So if we're going to minus, then our answer it will be haywire ring. Okay, done for the calculation. Simple calculation only. So next one, we go to question number 6. You see, so for February, March 2022, they actually have 2 questions they're asking you from the organic chemistry. Therefore, every season they have at least 1 to 2 questions. At least 1, but sometimes they got 2 questions. Therefore, organic chemistry and making a huge weightage. The weightage is very high. That means the percentage is like 2 out of 6 questions. You see, 2 out of 6 questions is 30%. No, all right. So now question number 6. So question number 6, you look at what is the groups, the homogeneous series. You see, propanoid, here. This one is what? OAT is what? Huh? Is it the ester or carboxylic acid? So look at, where is your table? Yes, here. Look at the table that can actually help you. You see here? Here doesn't have it. Never mind. You look at, if you don't have, then you can straight away look at the, this is alcohol. We have the OL at the back. See? Alcohol. We always have the OL at the back. Then how about the carboxylic acid? Okay, carboxylic acid, normally we will have the OIC at the back. Okay, OIC at the back. And ester, correct? So ester will always have the OATE. So the propanoid over here is actually considered the ester group, correct? Okay, now ester. You see, ester are family organic compound that's similar to chemical property. So they can be represented by the formula. So what is this? This is so-called the general formula. This is the general formula. So give the name to a family of the organic compound that have similar chemical property. Similar chemical property, meaning that like single bond or double bond or triple bond or alcohol, okay, alcohol or carboxylic acid is OIC or the ester is OATE. So what it is? So we have the 6 series, the group. What is the 6 series group? We call it homologous series. Yes, this one, you see? 1, 2, 3 is considered hydrocarbon. Alkane, alkene, alkyne is considered hydrocarbon because they only have carbon and hydrogen. How about 4, 5, 6? Group 4, 5, 6 is actually so-called non-hydrocarbon because alcohol, carboxylic acid, and ester, they're actually related. Who is the father of the whole family? The originated gene is actually from the alcohol, is it? Alcohol, when they oxidize, when alcohol has been oxidized, oxidation takes place, they become carboxylic acid. And when alcohol plus carboxylic acid, they'll form ester. So that means group 4, 5, and 6, they're not considered non-hydrocarbon because they have extra, more than carbon and hydrogen. They have extra oxygen. You see, oxygen, oxygen, oxygen. So they are not considered hydrocarbon. Hydrocarbon meaning that they only have carbon and hydrogen. Okay, carbon and hydrogen, carbon, hydrogen, carbon, hydrogen. This one, carbon, hydrogen, oxygen, carbon, hydrogen, oxygen. Right? So now, so our answer very simple. Here is so-called the homologous series. Okay, right now. Homologous series. Again, I test you how many homologous series we talk about. 6, 6. Alkane, single carbon bond. Alkene, double bond. Alkyne, triple bond. Alcohol, no. Carboxylic acid, OIC. Noid is OATE. So it's ester. Okay, next. Question 2. Any questions so far? Those who are online? Esther, Sujia, Summer, Ian. And those of you who are in the class? Good. Can or too boring already? Cannot tahan already. Cannot tahan. Okay, now. Okay, now number 3. Number 2. So explain why the number of the family organic compound have the similar property. Why they have similar? Yes, same functional group. Correct. Same functional group. Good. So you write down same functional group. So what do you still remember what it means by functional group? Functional group is this one. It's the single bond, the double bond, the triple bond, the OH, the COOH. Okay, CO double bond on the oxygen, COOH like this. Okay, COH, I mean without the hydrogen. Ester will without the hydrogen. The carboxylic acid will have the carbon oxygen double bond. OH is follow. Okay, OH like this. This is also called the functional group. Okay, give the name of the formula. What is the formula? That's how teacher already write down the name. They give you CN, H2N, blah, blah, blah. Well, what kind of formula we call this? We call it as general formula. Yes, too easy. So, general formula. Okay, what is the general formula for alkane? It's CN, H2N plus 2. Yes, good. CnH2n plus 2. How about alkene? Okay, 没有 plus 2, 对 CnH2n. Yes, good. Then how about alkyne? Alkyne you haven't studied, right? Never mind, you study in A level, but you learn now so that in A level you have no problem already. CnH2n minus 2. This is like kindergarten, correct? Yes. So done. Then how about the non-hydrocarbon, the oxygen group? Look at here. My page cannot write any longer. So this is the one. Alcohol is CnH2n. Instead of plus 2, alcohol become plus 1. Plus 1. Then don't forget the OH at the back. You don't be too excited. Oh, teacher say CnH2n plus 1. Then I forget the hydroxide. The OH you still have to follow. Yeah? The OH here you still have to follow. Then same thing, go to here. What is the tail? So the carboxylic acid also CnH2n plus 1, but they have the COOH. They still have the OH, but they have the extra carbon and oxygen double bond over here. This one. CO here is double bond like this. Then how about ester? Ester, the name will be twist. Ester will be a bit complicated. Their name will be twisting. The name will be twisting. The alcohol name we're going to write first, then followed by the carboxylic name. Okay, the alcohol name go first. Because why? Because they are actually from the alcohol family. Who is the grandfather? This is the grandfather. The alcohol is the grandfather. So we need to respect the old man first. Old man come first. Okay, alcohol come first. Okay, alcohol come first, then followed by the grandson. This is the grandfather generation. This is the father generation. This is the grandson generation. Okay, 他们是一个家族来的。Okay, right. So determine the number of. See, what is the formula for this one? Butyl propanoid. Where is the butyl propanoid here? I cut. Okay. So now they ask you to determine the N. So what is the general formula just now? CnH2n. So CnH2n, they give you already O2, right? Okay. So how much is the N? Cn, how much? Yeah, so we have to look at which one? You see, we have two, correct? We have two parts. So we have to look at the here and another one. So I cannot, I changed the color. So we have to look at the first one and look at the second one. In total, how many carbon? So this question asking you, in total, how many carbon? So the boot. So this one is not pronounced as bud. Mama eat papaya, but is a boot. So this one is equal to 4 carbon. 4 carbon. So this one, prop, mama eat papaya, 3. So 3 carbon. So you add up together, how many carbon? 7. 7. So this one add up together is 7. So the answer is 7. Like this. 这样子的. Okay. The answer, if you only give 3, not correct. If you only give 4, also not correct. So I mean they have to merge it together, because they say how many value of the n, meaning that how many carbon. So here they're actually asking you how many carbon. You see, because they're asking you this one, correct not? The n, right? How many carbon? So add up. Butyl is 4, prop 3. Okay, 4 plus 3, 7. So if you are used to this type of question, then you will be very happy every time the exam come out organic chemistry. Sure, you score 1. So, but we must know the tricks. Okay, we must know how the question actually going to ask us. Understand? So now, so you see, now they are asking O4 ester in the list are liquid at room temperature. Liquid at room temperature. So name the technique that used to separate the ethyl propanoid, to separate the ethyl propanoid from the mixture from 4 ester. So they are liquid, you know. So what process is suitable, whether we use fractional distillation or cracking? Which one do you think? Fractional distillation or cracking? Yes, because why? Because why? Because they say ester here is actually in liquid form. So how to separate? Because ester will contain alcohol and also the carboxylic acid, right? No point we're using cracking, because in cracking, that's how we already study. Cracking, they're actually using high temperature and high pressure. So in this case, we no need to be using so high temperature and pressure. So we're just using the normal process. Normal process, we call it fractional distillation. Normally in this case, we just boil it to certain temperature. Then the alcohol will be evaporated already, correct? Like this. Ester, 你知道 ester 用在什么地方吗？ Ester, ladies, your mom or boys here, gentlemen here, you wear any perfume or not? Ester is actually used in perfume. Perfume? Your sister or your mother using any coloring their nails or not? They didn't call it the nail polish. They got green color, pink color, yellow color, and whatever color they have. They actually is what? Ester as well. Then you like to smell the what they call the smell of the nail coloring or not? No? Hansi, you color your nail, your feet, is it? But you wearing stocking, then your school teacher cannot see. Then you color your nail, your what they call your 脚趾怎样讲 fingernail, I know. Feet nail, got feet nail. I don't know whether they got feet nail. All right, so this is all called the ester, right? Okay, now 4 ester can be made by reacting different alcohol with same substance. So name this substance and draw the structure. And show all the atoms that form the bond. So different alcohol with same structure. 4 ester can be made from different alcohol with same structure. So same substance. So you need to ask yourself first, how to form ester? Alcohol plus what substance? Yeah, so this is the carboxylic acid. Carboxylic acid, okay? carboxylic acid. So what is the name of the carboxylic acid that we're going to add with the probe here? Okay? The probe. This one, the original name of this one is what? Okay, you must able to separate like this, you must able to separate like this first. 你会分先哦。you were able to cut like this first. Okay, the left hand side, the methyl, the ethyl, the propy, the but, all these are what? 这四个是什么？ This four substance here, this four item here is originally we call it alcohol group, correct? Alcohol group, correct? The mean the methanol. The S means the ethanol, correct? The propanol, the butanol, correct? Then how about the propanoid here? All these are actually the carboxylic acid, the Ca here, the propanoid acid. Prop here is, what is the name? Propanoid acid. So you write down propanoid, OIC, okay? Carboxylic acid always OIC acid, like this, propanoic acid. I know some of our classmates or some students, they are always confused. This year, very confused. I don't know which one is which. It's like logic. Then I cannot differentiate. Then I just listen to your voice and talk only. Then I really don't understand. All right, so never mind. When you look at the name like this, so this is the root's name. The roots normally will follow the alcohol roots, the root name. Okay, the methanol, ethanol, propanol, butanol is actually the roots, the alcohol group, the root's name. Because when they change it to ester, the methanol, the NOL, they're going to change it to YL. Okay, the ethanol, you change it to YL. Propanol also YL. Butanol also change to YL. And this one, the propanoid is actually so-called the suffix, right? The suffix name, right? The suffix. So this is the root name. Root means mama eat papaya. Mama eat papaya, but Papa have his orange next door. Prop, but, pentagon, hexagon, heptagon, octagon, nanogon, decagon. So that's what? 5开始都是 pentagon 是五角星吗 ？Okay, so this is why we have a slogan: Mama eat papaya, but Papa has his orange next door. Yeah, this is the slogan. But you don't like this slogan, then you can say pentagon, hexagon, heptagon, octagon, nanogon, decagon. Okay, like this. All right. So now here come the structure. So probe, how many carbon first? The probe here decide the carbon. Mama eat papaya. How many carbon? Yes, 3. I heard someone say 3. Who? Yahweh say 3. All right. So yes, probe means decide on the carbon. That means 3. So how to do? If you already know this is a 3 carbon, then confidently we lay out the 3 carbon first. Because probe papaya, 1, 2, 3 carbon first. Then what you going to do next? Then link the hydrogen. Because you already know, right? Link the hydrogen. Okay, link the hydrogen. Link the hydrogen. Okay, then this side will be the propanoic acid. So propanoic acid, just now I told you is what? This one is propanoic acid. Yes, double bond O. Then you say, teacher, sometimes I see from the book, it's different from what you are giving me. It's like this, sometimes the books, they can draw the propanol acid like this. Then you ask me, teacher, like this can or not? Can or not? Yes, can. Whether you are 90° or whether you are 45°, acceptable lah. You see how you're going to put the angle only, right? You cannot be always your head will be straight, right? Always time, when you're sleeping the time, your head will be twisting also, right? Then you put your thing nicely 90° all the time? No, right? Okay. Hansi? Huh? So now, meaning that here you're going to draw. Let's say you want to draw nicely, then you draw nicely here lah. Oxygen. Okay. Then I use the bold one. O like this, then follow the O, then follow the O like this. Then just now, if you, let's say you don't like teacher drawing like this, then you also can change. You also can draw the double bond oxygen like this. Then this one, O and O like this. But normally we're going to draw it properly. Okay, we draw it properly like this. Right. So this is so-called the propanoic acid. So propanoic acid will be COOH. So I like you separate the OH like this. Normally the marker examiner, they don't like you to write the OH together. So when we mark the time, the H, normally we're going to separate it like this. Okay, next one. Next question. Name the alcohol that used to make methyl propanoid. So now you tell me the methyl propanoid, which one is alcohol, which one is carboxylic acid? First one is the alcohol or the second one is the alcohol? Yes, first one. So that means this one we separate like this. This one is the alcohol, and this one is the carboxylic acid. So what is the alcohol to use this one? You see the YL. So what is the original name? Before he get married, what is the original name? Alcohol, we have the NOL at the back, correct? Okay, alcohol, we have the NOL at the back, correct? So we have the METH, the YL. We just cut the tail, so become methanol. Okay, methanol, like this. See, sometimes the question already got the answer. Just that we don't panic. We need to know who is the grandfather, who is the father, and who is the grandson. Okay, understand? Understand? You must know the grandfather generation give birth to the father. Then the father generation, together with the grandfather generation, give birth to the grandson. You cannot be the grandson married the grandfather, no. You get what I mean? So some students, they are confused. You cannot twist it another way around. Okay, now next one, question D. Question D. Question D. So other ester not in the list. Why they are always think out of the box one? They say not in the list. So have the same molecular formula, propyl propanoid. Propyl propanoid. Prop means how many? You ask yourself, sir. Prop, how many carbon? Mama eat papaya, 3. This one, prop, how many carbon? 3. Propanoid, prop, 3. 3 plus 3. Total how much? 6 carbon. This one, Now you're good already. So cannot cheat you anymore, right? So your propyl got 3. Propanol also got 3. So add up to be 6 carbon. So 6 carbon, what is the general formula? For, I don't care what is the general formula now. So N2 N plus 1, isn't it? We don't care the H now, but most importantly, we know the carbon first. The rest of the hydrogen is not that significant. So now, state the term that used to describe the substance that have the same molecular formula but different structure. Same molecular formula but different structure. Isomer, yes. So what? For example, you have the what? For example, you have hydrogen, H2, and H3, correct? This is so-called isomer. For example, you have the carbon, you still have carbon, for example, have a carbon 14 and carbon 16, for example. This is so-called isomer. So you know when Japanese release, Japan, the country, actually released the what? The Fukushima, what the nuclear plant, the wastewater. This is the tritium, right now. 3 hydrogen. This is a tritium. The tritium that released into the seawater. So tritium is actually the H3. Right now. This is what? H1 is considered what? H1 is hydrogen ion. H2 hydrogen gas. Right? Yeah, so they still hydrogen. Yes. So the answer should be what structure? They ask you what structure? Different structure. So we call it structural isomer. Okay, structural isomer, meaning that they have the same molecular formula but different structure. So now this question is a bit creative. Question number 2. 2 ester with same molecular formula of the propyl hepanoid. So how are you going to form? So ester, you see, ester must have the name. What is the tail? The name of noid, must have the N-O-A-T-E, the noid. So that's how we know that. That's how we already write down. How many carbon? Prop is 3 carbon. The prop is 3 carbon. So 3 plus 3 in total must have 6. Meaning that we need to give the name of this one plus this one will equal to 6 carbon. Whatever name you give, you must become 6 carbon. For example, this one, the number 2 also. Whatever name you give, you must have the 6 carbon. So can you give the combination? Alcohol name first. Alcohol name first. But remember, you must end with the YL. You must end with the YL. Here, you must end with the NOAT. This one, you must end with the NOAT. OK， 可以吗？你给我什么加什么等于6？So it is 2, right? 2. So then you give the first one is ethyl. Ethyl 这个前面是2吗？ Then 后面一定要4是什么 ？Prop 是吗？But so butanoid like this. That means here you give 2. Here you have 4 like this. Then become 6 So this one I just rub. 你不要加的，你这样连起来。So you write it together. You don't need to use the plus, but for my explanation, I use the positive sign only. So for for us to do exercise. Then another one. So the first one is 2 plus 4. What? Then other example, 4 plus 2. Well, you're too easy like that. 2 plus 4, 4 plus 2, then you don't need to think other thing. 4 plus 4, 8 already cannot. 1 plus 5, can? Can. You write 1 plus 4. 1 plus 5 is what? Methyl pentanoid. Pentanoid. Okay. Mama eat that methyl pentanoid. So then, okay, then you don't need to be so complicated. Then okay lah, no problem. You can write down this one, like what Hansi just now said, is it? 4 plus 2, right? 2 plus 4, then 4 plus 2, can? So then this one you just write down butyl ethanoid. Butyl ethanoid, like that. Okay. As long as the total of the carbon is equal to 6. Because why? Because the propyl and the pentanoid just now is actually equal to 6. The combination like 2 and 4, 4 and 2, 3 and 3. 3 and 3 already give to you, so you cannot use 3 and 3 anymore. You can use 2 and 4. 1 and 5. 1 and 5 just now already give you an example like Mama eat methyl pentanoid. Okay, now polyester. Polyester also called what? Polyester, another name also called PET. PET, plastic, polyester. The polymer, the PET is actually like we make the polyester, the polymer. Okay. The PET is actually used to make the mineral water bottle. This is the polyester. Okay. So now the first one, you need to identify what is this first. Just how teacher say COOH is what? Double bond. Yes. COOH. This one is, you know, that is carboxylic acid. Carboxylic acid. This one is what? OH. OH is single bond. Yes, correct. Cannot draw too fast. This one is single bond already. They tell you single bond already. Okay. Got mistake, you tell me lah. All right. So Damon completes. You see, complete the 2 molecules, include all the atom and all the bond in the linkage. So how we're going to add together? So this one we need to plus together with this one. So plus together with this one, we call it the process of condensation. You must remember the process of condensation. We need to get rid 1 molecule of H2O. 我们一定要丢掉一个 molecule 的水。Okay, 1 molecule of H2O must get rid of it because you need to combine together. Okay, you need to combine the monomer. That means 2 molecules together. So you need to get rid of the H2O. So how to get rid of H2O? That means the H2O you need to potong. How to potong the H2O? Cut. You need to cut the H2O. So that means where is the H2O? That means this OH and another OH over here. You need to cut. And how about another H? Where we need to take the cut from another H? Another H will be cut from here. Cut here. Cut here. 头跟尾 cut 掉。potong, you know? The extra water we cut it. So now can you draw or not? Now can you draw? So you cannot include the H2O. You cannot include the H2O. Right, so now, can we draw together? Now, teacher already crop out from you. Crop out for you. Okay, so now you need to, this one you need to, maybe I use the red color. So you cut the OH now. You cut the OH now, like this. This one will connect to the O, correct? This one you connect to the O. Okay, then this one you connect to this guy over here. You see, this one you have to connect to the O. Then this one you can have to connect to the C. Then O. Can you see what I'm drawing? 你看得出老师画什么吗？ Then you just follow here. Then this one you just follow lah. This one the gray color here, the gray color here. So you just follow. What you're looking at? Look at the TikTok girl. Is it? Huh? Who? The TikTok girl. Why you always look at the TikTok 小姐姐啊? Wow, can't see. Okay, so this one, the C, and this one, O. Okay, then this one, maybe you draw longer a bit. Okay, you draw longer a bit. This one, you can draw longer a bit. What do you mean longer a bit? Longer a bit like this. Okay, this one C, this one O, this one like this. Okay, this one O. Okay, this one O, then this one C like this. O. Okay, so this one C. 看得懂吗？诶，这样子啊，只是从上面割下来吧。诶，你白色对白色，黑色对黑色。So we need to take out one molecule of water because the process of condensation is get rid of the water molecule. It's like this. So this one will form the polyester. So we call it polyester. Polyester. Okay, polyester. You see, HO and H is H2O, right? This one also HO and H is H2O, right? That means when we combine, then this one sacrifice the H and O, this one sacrifice the H. OK， 它这边要丢掉一个 H， 这边要丢掉两个，所以它就变成有一个 water molecule form. OK， so then it will become like this. So when you cut the OH over here, then this oxygen is actually taken from the carboxylic acid here. See, the double bond is over here. Yeah, this one. You see, then the gray color, then the double bond again, oxygen, then the white color. Okay, the oxygen is actually from here. This one, oxygen. Okay, yeah, like this. Okay, then name the type of polymerization that takes place when polymer form. So what is the process name? Condensation. Just how teacher already give you the answer, right? So name the type of polymerization that takes place. Polymerization meaning that the process to become polymer. So get rid of one molecule of water. So the answer is condensation, meaning that you need to get rid of H2O. So name a polyester. So you always can refer to this one. You see, this is our Z note, the express note that I sent it to you earlier. For those of you who are joining our classes earlier, because teacher actually using this express note to explain to you, right? So that you are more understand. So you see, this is a molecule of water to get rid of. You see, H is here, H2O. That means one molecule of water is actually throw away from here, right? Then one example of the polyester. Polyester, what is the name? You can write down, this one is a terylene. Okay, terylene. You see, pteridine. So the pteridine, what is the bonding just now? Is like this. This is the bonding, right? So you write down pteridine. Pteridine. Terry. Any of your friend named Terry? Yes. Who? Terry Wong? Is it Henry Wong or Terry Wong? Harry. This one, Terry. Mm. Mm. Or not Harry, not Prince Harry, the Harry. Terry. My last time, my Chelsea soccer player, Chelsea man, Chelsea also named Terry. Old retired, the old guy. Terry. Terry same batch with Lampard. Terry. You know, you if you like football, you know Terry. Lampard. You know Lampard. Yeah, when you go to Terry. Terry and Lampard. These two guys, Chelsea. I mean Chelsea team. This one is Terry. Lampard. This is Lampard. Terry. He is Lampard. Sound weird, right? Why are you laughing? No, I mean, this is real. Chelsea, the captain. Terry is the Chelsea captain. Retired already. Yeah, retired. Yeah, Lampard. Lily. The name is Lampard. You look at the internet, you go Google. Okay, now question 6. Question 6, November 2021. Ethanol belong to a homologous city called alcohol. You see, a lot of information over here. Ethanol, mama eat 2 carbon. Homologous city called alcohol. So what is the general formula for alcohol? Yes, correct. So CnH2n plus 1. Then who must got the tail? What is the tail? The OH. OH is the tail. The hydroxide is belong to the hydroxyl group. Hydroxyl is a group. Hydroxide is one of the member. Okay, next. Question number 2. Explain why ethanol cannot be described as hydrocarbon. Just now teacher already explained very lengthy about hydrocarbon. Hydrocarbon only have what? Only hydrogen and carbon. That's why we call hydrocarbon. This one have what? Oxygen, correct? So how you gonna answer? So you can say not all atoms are carbon and hydrogen. Or you can say, you also can say ethanol has what? Has carbon, hydrogen, and oxygen. Okay. So you can say ethanol has carbon, hydrogen, and oxygen, not only carbon and hydrogen. Okay, next question. Next question. Ethanol can be manufactured from different substances by 2 type reaction. One is actually by steam. Steam means through the addition process. Reaction with steam means that addition process with we call hydration with water. Steam means hot water vapor, or fermentation. Fermentation is actually using yeast. So one, give the formula of the substance which react with steam to form ethanol. Huh? Give formula of the substance which react with steam to form ethanol. So what is this? What do you think? Give formula of the substance. Formula of the substance that react with steam to form alcohol. What is this? We're using what? To plus steam then form alcohol. Huh? Still remember? Still remember? Addition. Okay, so look at the note that we discussed previously. So we have 5 process of addition. This one. You see? Addition of water. Look at number 4. Addition of hydration. You see? Addition of water. Then you go to addition of water. Where? Preparation of ethanol. The fermentation of glucose and hydration of ethene. Yes, this one. So now you write down. Put over here is the answer is actually ethene. But what the answer asks you to write is the formula only. They don't like the name, They want the formula of ethene. So formula ethene you need to write down is C2H4. This question is consider higher thinking skill. They didn't ask you to write the name of ethene, but they ask you to write the formula instead of the name. You must write the formula of ethene. So if you give the name ethene, then wrong. Okay. Remember, during the addition of water process with ethene to become ethanol. Ethene plus H2O, water, then become ethanol. Why? Because we know that ethene is double carbon bond, then they can change. You cannot use ethane. You cannot use ethane. Ethane is single carbon bond. So it's saturated already. The maximum pairing already. Cannot. Okay, next one. Name the substance which will undergo fermentation to form ethanol. What is this? What will undergo fermentation to form ethanol? A substance that will undergo fermentation. Substance which undergo fermentation will be glucose, It's not yeast. Yeast is the plant cell that will fermentate the glucose. The glucose will undergo fermentation. Glucose is the substrate, it's the food substrate that used by the yeast during the process of fermentation. So the answer will be glucose. So ethanol is a fuel. So write the chemical equation for complete combustion. Complete combustion. Complete combustion meaning that complete, or we call it fully burned. 100%. Fully burned. And some students will ask me, teacher, what is the difference between fully burned and partially burned? You see, the question said complete combustion. So what is the difference between complete and not complete combustion? Incomplete, they will not produce carbon dioxide. They will produce carbon monoxide. Carbon monoxide. Complete combustion will produce carbon dioxide only. Okay, no CO. CO means carbon monoxide. CO2. Okay. Fully burned means they will produce carbon dioxide. So partially burned means incomplete. Incomplete, they were going to produce carbon monoxide. Carbon monoxide is CO, poisonous gas. So what is the equation? Ethanol first. Ethanol, they give you what? You just follow. They will give you, they give you the ethanol. So you just follow the equation on the top. So you just write down C2H5OH, correct? Then plus the balancing, you do it later. You don't care about the balancing first. Balancing, you do it later. So plus oxygen. Okay, then it will give you what? Definitely the complete burn will give you water vapor. The balancing, you do it later. Water vapor and also the CO2. Okay, CO2. So now do the balancing. How many oxygen we left out? How many oxygen in total left out? This one oxygen, then one oxygen, two over here. Never mind. Later we check. So H, how many H here? Five. So how? 6. You see? We got 5 over here. We got 1 H over here. 6. 5 plus 1, 6. So how to get 6? 这边有5个 hydrogen 加1个6个6个这边2个3 2 6啊。So 3 over here, correct? Understand what I'm saying? This one got 2, correct? This one 5 plus 1, so equal to 6. So this one 3, 3 times 2, 6, 3 times 2, 6. Okay, so check. So now 3 oxygen, 3 hydrogen is actually balanced already. So oxygen, how much? 3 oxygen. This one don't know yet. We look at carbon. How many carbon? 2 carbon here. This one also have to be 2 carbon. Here got 2 carbon. This one also have to be 2 carbon. So check the oxygen, correct? 2 and 2, 4. 4 plus 3. This one become what? Sorry, 2. This one got 1 more. Okay, this one got 1 more. You see oxygen here. So this one, how the blank of the oxygen over here? 3 oxygen over here, 4 oxygen over here. So we have totally we have 6, 7 plus 1 is 7. So this one is 6. Then it becomes 7 already. 3, 2, 6 plus 1, 7. 3 oxygen plus 4 oxygen, 7. Yes, balance. Okay, so this is how to do the balancing. Okay, okay, so maybe we can quickly finish the rest. Okay, ethane 1 and 2 dies has 2 oxygen functional groups. So 1 molecule of the ethane 2 dies will react with 2 molecules of ethanoic acid to form molecule X. Okay, this is ethane, and this is the will react with two molecules of ethanoic acid to form molecule X. So X has two ester functional groups, and molecular formula is this one. So what is the empirical formula for the X? Empirical means the simplest one. Okay, what is the simplest molecule for this one? This one. So you see, X has two ester functional group and a molecular formula of C6H10. This one. So we just use this one. This one. Okay, they already give you. So what is the empirical formula for this? This one. You see, the O over here, we've got 4. We use the smallest number. Empirical formula, always look at the smallest number. So how to divide? We can divide by 2. See, we cannot divide by 4, but we divide by 2. You see, we divide by 2 over here, like this, huh? You cannot divide by 4. Then I divide by 2 over here. This one divide by 2. This one also divide by 2. So I get C become 3, H become 5, O become 2. This is the answer. This is the answer. You see, the ester have functional group and a molecular formula. They give you the formula already. Right? So you don't need to crack your head. Hey, teacher, wait, how I been going to write the formula? Formula already given to you. See? The molecular formula already given to you. So you need to make it to the simplest form. In mathematics, we call it simplest form. So in chemistry, we call it empirical formula. So what is the smallest common factor? This is the lowest common factor in your mathematics. That means you divide by the that means divide it into the smallest common factor. That's all. So now we need to draw the structure of X. That means you draw this guy. Okay, you draw this guy. So how many carbon? 3. Okay, draw 3 carbons. 1, 2, 3, like this. Draw the 3 carbon first. Then hydrogen. So you know that this is an ester group, right? So that means hydrogen, 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 hydrogen. So 1, 2, 3, 4, 5. So how about oxygen? COO, right? Yeah, COO. At the back. See? Like this. And where is the table just now? COO, okay? COO like this. So you can actually draw like this, or you can also draw like this. If you don't like to look like this, then you can draw properly, like a good boy, or or like this. Okay, done. So why you ask, why teacher the O have the double bond with the carbon? I already told you in the another day, right? One carbons can marry how many wives? 1, 2, 3, 4. Yes, this is single bond. How about double bond? Now this carbon already got 2 wives. So can you marry some more? Yes, married another 2 only. Then now this carbon already got 3 wives. Can you marry some more? Yes, 1 more extra only, like this. Okay, therefore, how many bonding over here? You see, the bonding here got 1, got 2. That means 3 and 4. Right? Okay, name other substance form from this reaction. So it's water. Water, because we know alcohol plus carboxylic acid. So ester will form ester and water. Okay. So maybe we drag too much. Maybe you try to do the question number 6 and the rest. So today maybe we can stop until here because other classmates already come in for the next lesson, the next subject. All right, so that's all for today, everyone. You try to do the rest of the question, then later on, maybe the next class we can discuss the answer. And because of the exam is coming, so this month we're going to have a few extra class. Okay, this month we were going to organize a few extra class for you for chemistry, especially. All right, so that's all for now, everyone. Got problem? Please send it to our group, and don't keep on laughing on Lampard. Is my soccer football idol, but it's retired. Okay, all right. Thank you, everyone. Bye bye.